All right, so in this video, we're going to give some broad intuition about another empirical strategy that's a bit different and maybe a little bit trickier than some of the strategies that we've talked about so far, and that's instrumental variance. So the idea here is that you want to estimate the effect of some variable D, some treatment variable, on our outcome variable Y, right? But you don't have a treatment variable that's randomly assigned, right? But maybe there's some other variable, Z, which we're going to call our instrument, that we can use to try to get at the effect of D on Y, right? So if it's the case that we have this other variable that has a causal effect on treatment, so there's something about this variable Z that makes you more likely to receive the treatment, right? That's the first condition. It's always going to make you more likely to receive the treatment, or always going to make you less likely to receive the treatment. But in most cases, we're going to sort of, in our typical case, we're thinking of Z is going to make you always more likely to receive this treatment. And this other variable Z is as good as randomly assigned, right? So we do have some nice random assignment with Z, but Z isn't exactly the treatment that we're after getting the causal effect of, right? And then this is an important one that's easy to kind of forget about. The only way that Z affects our outcome is through its effect on whether or not we receive the treatment. So this can be a little bit tricky to think through, but let's take a current example, right? Let's say COVID makes you more likely to work from home, right? And we want to use that as our instrument for this treatment variable of working from home. Well, that's all well and good, except that there's other stuff that COVID is affecting beyond just our treatment variable. So if we were trying to look at something like people's incomes, or whether people lose their jobs, and we wanted to use COVID as an instrument for working from home and getting the effect of working from home on that outcome, that would violate our exclusion restriction, right? Because COVID is also causing people to lose their jobs and having all these other effects itself, not just through the forcing people to work from home more often, right? So the key thing to remember is our instrument only operates on the outcome through affecting the treatment, and that can make it sort of tricky to think of some good instruments, right? And it can actually be quite hard to come up with good instruments in a lot of situations. So if these other things are true, right, if these conditions are met, that means that the part of the variation in the treatment that is caused by this variation in the instrument, right, that part of the variation in treatment is not going to be endogenous, right? It's that part we're basically going to be able to get a nice estimate of the effect of the treatment on the Y from just that piece of the variation that's explicitly driven by the instrument. Okay, and so that might be a little bit vague at this point, but we're going to use an example to try to give a little bit more concrete understanding to what I mean when I say that. Okay, but let's do this little video first because it's kind of fun. So this is the basic idea, right? We're taking just the part of here it's labeled X, but really this is our D in our example. This is our treatment variable, and we're saying how much of that is explained by this variation in the instrument, right? So we're going to look at just, accounting for that change in the instrument. We're looking for just what's left in the variation in X that's due to the instrument and what's left in the variation in y that's due to the instrument, and we're going to look at the slope there. Okay, so maybe that didn't clarify too much, but hopefully we'll get to it when through looking at this this example here. So here we have an example where we've got a charter school lottery. This is a common use of an instrumental variable. We have some sort of lottery, and the lottery gets you eligibility to receive the treatment. Doesn't necessarily get you the actual treatment, right? So in this case, we want to look at the effect of attending charter school on some math test score. But what we're going to have is not randomly assigned attendance, but randomly assigned eligibility to go to that charter school. So students are offered a seat in a charter school based on some lottery. We're going to call our instrument zi is going to be an indicator equal to 1 if student I is offered a seat at a charter school through the lottery. Right, and remember there's a difference here because some students are going to be offered seats but decide not to attend, right? And then some students might not be offered but may end up attending. They might get in through the wait list, or there's some other ways you might be able to get in without that. But the part of the variation in attendance that is driven just by whether or not you win the lottery, that's the part that's going to be random, right? Or that's the part that's going to be that's not going to be endogenous. We can use that part to get at the effect of attendance on these math scores. Okay, so we're looking for the causal effect of attending charter school, right? This is DI. Here's our treatment effect. This is, did you attend charter school, right? We know that this is not randomly assigned. There's lots of reasons why people attend charter school. Maybe they have different abilities than the people who go to public school. Maybe they have different incomes from their family. All sorts of different reasons, right? So we know that this is not going to be exogenous. In other words, there's going to be some relationship between DI and our error term, right? Some correlation there, right? So we've got some selection bias, in other words, the way we've been talking about in previous previous videos. Okay, so we can't just take a regression here and look at the effect, look at beta 1 and say that's the effect of attending a charter school, right? Because that's going to be biased because of this selection. So here we have our setup from before, where we've got, we're looking at the outcome. So here we have the observed outcome for the treated group, the observed outcome on average for the non-treated group, non-treated students. So these are students that attend. The average score for students that attend minus the average score for students that don't attend, right? And remember, we did the same thing that we had before, where we're adding and subtracting this counterfactual, where here the counterfactual is, the average potential score, in this case, if they didn't attend, for the students that did attend, right? And so we've added and subtracted that. And so we break this down and we've got our average causal effect on the treated group, right? Sometimes we call that the treatment on treated. We've mostly just been talking about it as like the average causal effect, assuming that it would be the same on these different groups. So we've got that, and we've got our selection bias here. So same ideas we've had in the past. What we're going to add to this, let's put this down here, maybe. What we're going to add to this is this IV piece, right? So we're looking, for starters, we can look at the causal effect of this offer, of being offered a seat on your math test score, right? Because that is randomly assigned, right? We know that the seat offer, which is this ZI, right? That's going to be as good as randomly assigned. That's our independence assumption, if you remember back a couple slides. It's only going to affect Y through its effect on D. So it's only going to affect the outcome through its effect on whether or not you attend. That's our exclusion restriction, right? There's nothing about winning this lottery that is going to like make you better at math, unless it's coming from, you know, giving you that opportunity to actually go to the school, right? It's not something like you're also, you know, and you also get $1,000, right? Right. So there's this, the exclusion restriction is going to hold. The effect is just coming through our treatment variable. And so we've got this correlation between ZI and UI is going to be, I think that's supposed to be equal to 0. So our OLS estimate of alpha 1 is going to be unbiased, right? So this should be, oops, let's just make sure we're being totally clear here, and we will make that an equal sign. Okay, so our OLS estimate of alpha 1 is going to be unbiased, right? So we can say, we have a nice situation to say, like, what is the causal effect, what is the average causal effect of being offered a seat at this charter school, which is nice. And so, in a lot of cases, that's a useful thing to estimate, but it wasn't really what we wanted to get at in this case, right? We wanted to get what's the effect of attending this charter school. Okay, so thinking about the causal effect of a seat offer, right? This is just putting this in the potential outcomes framework in the same way that we had before, right? We've got our observed average difference between the scores of the people who are offered versus not offered the seats. And here we have this average causal effect of a seat offer. Sometimes that's called the intent to treat effect. So these are the people that were intended to be treated, right? They were given the opportunity to receive the treatment. And then we've got our selection bias here, which, as we just said, since there's no correlation there, right? Since this is, the seat offer is randomly assigned, this is going to be 0 here. Okay, so that's our what we call our reduced form estimate, which gives us that intent to treat effect, or the effect of the seat offer in this case, right? Okay, so then we have our second piece. So we got our first piece is our reduced form, right? Where we're looking at the effect of the offer on the outcome. Now we're looking at the first stage, which is the effect of the offer on attendance, right? So if you're offered, how much more likely are you to actually attend this charter school, right? So notice here, our dependent variable is now that treatment variable, right? So because we're looking at, like, what's the effect on the likelihood that you receive this treatment based on whether you receive that offer. So if seat offer Z has a causal effect on attendance, then the correlation between ZI and DI is not equal to 0, right? Right. We've got this gamma 1 is going to be, doesn't necessarily need to be greater than 0, but it's going to be, the magnitude is going to be greater than 0, right? There's no 0 effect. If we get a 0 effect, if there's no first stage, then we can't really have an instrumental variables estimate, because the variation in our instrument isn't causing any variation in treatment that we can use to get at the effect of the treatment on the outcome. Okay, so here we have the same idea, just looking at the first stage, right? So we're saying, how much more likely are you to get treated if you're offered versus how likely are you to get treated if you're not offered. Observed difference in the likelihood of treatment. So the average causal effect of a seat offer on attendance, we call this the first stage effect, right? So it's like we got our first stage and we got our reduced form. Those are the two pieces here, right? And because we said these offers are randomly assigned, we wouldn't expect these things to look any different, right? That you know, how likely people were to go to the charter school if they got the offer. Let me rephrase. How likely people would have been to go to the charter school if they didn't get an offer, for the group of people who got the offer, would look the same as for the people who didn't get the offer, right? Because those offers were assigned randomly, right? So those two groups of people look the same. So you take those offers away, and they'd both be going to this charter school at the same rate. Okay. So we're killing the selection bias there, right? So with our instrumental variables estimator, what we're going to do is we got these two pieces, right? So the first is we're going to find the reduced form effect, that effect of the offer on the score, right? So in other words, what was the average of that score for the people who got the offer versus the average of the score for the people who didn't get the offer. Remember, there's no selection bias there because that offer is randomly assigned, right? If we were doing that with a regression, it would look like this. Okay, so we have some numbers here from a study. I think there's a missing negative in here, but basically the idea was, people did better on this sort of standardized score of math if they were offered a seat on average than if they weren't offered a seat on average here, right? So we get some reduced form estimate of 0.355 from being offered a seat at this charter school. The first stage effect, right, that effect of the offer on attendance, we can think about it in the same way, right? We can think about with this regression here, where DI is our dependent variable, or we can think about it in the potential outcomes sort of expected value framework, right? We're basically just comparing the average, so the rate at which people go to the charter school for the people who are offered a seat versus the rate that people go to the charter school for the people who are not offered a seat. Okay, and in this example, 78% of the people who were offered a seat took it, or 79%, and about 5% ended up going even if they weren't offered a seat, right? So you see, if we had like a perfect kind of randomized controlled trial, we'd have the same sort of thing going on, but this would be like, this guy here would be a 1, and this guy here would be a 0, right? If there was like perfect compliance, but we have a situation where there's not perfect compliance, so that's where this IB is gonna come in handy for us, right? So we got a first stage effect of 74 or 74%, right? So if our independence and our exclusion restrictions hold, which probably do in this case, then we've got, what do we got? We've got the effect of the offer on the score, right? That's our reduced form. And that reduced form is going to be a combination of the effect of the offer on attendance, that's our first stage, times the effect of attendance on our test score, right? So with our estimate so far, we know this piece here, we know this piece here, right? That's what we had above. So this guy was, this was our 74.74. This was our 0.35. But what we really want is this guy here. We want that effect of attendance on our test score, right? To answer our research question here. So the effect of attendance on test score is going to be, we just rearrange this equation here. We divide this guy over to the other side, and we've got, sorry, not this guy. We divide this guy over to the other side, and we've got the effect of attendance on test score is equal to the effect of the offer on the score, right? That's a reduced form divided by the effect of the offer on attendance. That's our first stage, right? So that's kind of instrumental variables in a nutshell. Do I go through it? Yeah. So our IV estimate, I'm not going to go too much into the details. This is sort of how it's calculated. It looks a little bit different than your OLS estimate. In terms of expected value, this is what we've got, right? We're just taking our reduced form, and we're dividing it by our first stage, right? No, I didn't need to do that. So we're taking a reduced form, dividing by first stage, right? If we were running those separate regressions, we'd have that alpha 1 estimate divided by this gamma 1 estimate. So in this case, I'm gonna move us back to the top here. So in this case, we'd have 0.355 divided by 0.78 equals this guy here, which would be our, when we talk about instrumental variables, we talk about the local average treatment effect, because we're not getting kind of the average treatment effect for everybody, right? We're getting kind of what is the average treatment effect for people who are actually going to be affected by this instrument, right? Because we're only looking at the variation in our treatment for the folks that are going to be impacted by these this variation in the instrument. Like the people who weren't ever going to go to this charter school, they're not going to sort of factor into the variation that we're using to estimate this, right? Yeah. So in layman's terms here, we're finding what's the effect of being offered a seat in this charter school, and we're then accounting for the fact that, you know, so we're comparing people who are offered and versus not offered, right? What's the difference in their test scores? But then we need to account for the fact that not everybody who was offered a seat actually ended up going, right? And that's what this dividing by 0.78 is doing, right? We're taking that into account and saying, okay, well, if test scores went up this much, but not everybody actually ended up going, we gotta account for that, right? So they actually went up by more for the people who actually ended up going.